Our topic, reasoning about contexts with tape diagrams, part 1. So our focus question today, how can you make sense of situations using tape diagrams? So for this question up here, we have two tape diagrams. Our first question, what do you notice? What do you wonder? So we notice they have some different variables in here. These have A, B, and C. This one down here has some X's, a Y, and a Z. We notice that the C and Z, there's numbers up here at the top. In the first diagram, we have 4 boxes with A and B in them. And the second one, we have 4 X's. I wonder what those mean. Do all these X's represent the same amount? Is Y different because it's bigger? Does that mean Y has a bigger value than X? Do all these boxes, because they're the same size, do they represent the same amount? So these are questions you might wonder about. So what are some possible values for A, B, and C in the first diagram? Let's just make some up. If A is equal to 1 and B is equal to 4, I wonder what C would be equal to. Well, if this is 1 plus 4, so that would equal 5, and this one is equal to 5, that one's 5, and that one's 5. 5, 10, 15, 20. So C would have to be equal to 20. Let's look at the second diagram. Let's make X equal to 2 and Y equal to 1. And let's see what Z would be equal to. So if X is equal to 2, that would be 2, 2, 2, and 2. And if Y is equal to 1, that would be 2, 4, 6, 8, and 1. Z would be equal to 9. Problem 2.2. Every picture tells a story. Here are 3 stories with a diagram that represents it. With your group, decide who will go first. That person explains why the diagram represents the story. Work together to find any unknown amounts in the story, then switch roles for the second diagram and switch again for the third. Okay, number 1. May made 50 flyers for 5 volunteers in her club to hang up around school. She gave 5 flyers to the first volunteer, 18 flyers to the second volunteer, and divided the remaining flyers equally among the 3 remaining volunteers. So we want to describe what are the parts of this diagram that reflect the parts of the story problem. Okay, so let's look at the story problem first. She made 50 flyers. So here's 50. So that probably represents the 50 flyers. And see these little brackets here? This picture is all of those 50 flyers. That diagram is all 50 flyers. Then she gave 5 flyers to the first volunteer. So here's a 5. So this must be the first volunteer. 18 flyers to the second volunteer. So here's an 18. That must be the second volunteer. And divided the remaining flyers equally among the 3 remaining volunteers. So here is 3 boxes, and they all have an X in them. So when you're dealing with variables, normally the variable letter indicates a number. So since these are the same letters, that means it's going to be the same value also. So these are the 3 remaining volunteers. All right. So let's see if we could find these unknown amounts that the 3 volunteers have, the flyers that were given to them. So we know that this total amount is 50, and this amount here, 5 plus 18, that's 23 flyers. So we have 23 flyers, plus we have this unknown amount here. So 23 plus something is 50. So let's see what this something here, these three volunteers, let's see how many flyers they have altogether. So if we take 50 and subtract the 23 flyers that we have here, we end up with 27 flyers. So whatever amount they each have, their total is 27. So if they have each have the same amount, we could take that 27 and divide it by 3. So together they equal 50, but let's figure out this 27. So 27 divided by 3 is equal to 9. So that must mean that each volunteer has 9 flyers. So 9 plus 9 plus 9 plus 18 plus 5 is all 50 flyers. So let's look at problem number 2. To thank her 5 volunteers, May gave each of them the same number of stickers. Then she gave them each 2 more stickers. Altogether, she gave them a total of 30 stickers. So 30 stickers total is this amount. And we have 1, 2, 3, 4, 5 boxes in our tape diagram. So those are our 5 volunteers. Our 5 volunteers is each of these boxes. So let's see what these numbers and variables represent inside the boxes. May gave each of them the same number of stickers. Then she gave them each 2 more stickers. So here's the number that she originally gave them. And then she gave them each 2 more to equal 30. So if they all have the same number of stickers, we have 1, 2, 3, 4, 5. So if we take 30 and divide it between the 5 volunteers, 30 divided by 5 is equal to 6. So that must mean the total that each volunteer has is 6 stickers. So what number plus 2 is equal to 6? So 4 plus 2 is equal to 6. So y is equal to 4. So she gave them 4 stickers, then an additional 2 stickers. Number 3. May distributed another group of flyers equally among the 5 volunteers. Then she remembered that she needed some flyers to give to teachers, so she took flyers from each volunteer. Then the volunteers had a total of 40 flyers to hang up. So this number, 40, is the number of flyers after she took 2 away from each volunteer. So she gave some to each volunteer, took away 2 from each volunteer, and ended up with 40. So if we have 5 volunteers, and they have a total of 40 now, what did they have before? How much did she give each one? So 40 divided by 5 is 8. So that must mean that each volunteer now has 8 flyers. But that was after she took them away. So how many flyers did she give them before she took 2 away? So the number of flyers minus 2 is equal to 8. So that must mean the original number she gave them would be 10, because 10 minus 2 is 8. So let's look at this problem a different way. Let's see if there's another way we could look at this. So if we just look at the number of flyers she took away as a total number of flyers, she took away 2, 4, 6, 8, 10 flyers away. So if she took away 10 flyers and now has 40, if we take 40 plus 10, that must mean she had originally each person, we have 5 volunteers, and the total before she took them away was 50, so that means each person must have had 10. So that's another way of looking at it. So the original amount was equal to 10. And then you take away the 2, 4, 6, 8, 10 total flyers, which gives us 40. Okay, let's look at problem 2.3. Every story needs a picture. So now we're going to be making the tape diagrams that represent the story. Here are 3 more stories. Draw a tape diagram to represent each story, then describe how you would find any unknown amounts in the stories. So number 1 says, Noah and his sister are making gift bags for a birthday party. Noah puts 3 pencil erasers in each bag. His sister puts X stickers in each bag. After filling 4 bags, they have used a total of 44 items. So the first thing I'm going to do is I'm going to draw a rectangle representing the total amount. Okay, so my total amount I know is 44. So this is my total here. And they have 4 bags where Noah puts 3 erasers and his sister puts X stickers. So we have 4 bags with the same number of items in them. So I'm going to make 4 equal parts, and each one of these parts represents a bag. So now I'm going to start with what we know Noah puts in: 3 pencil erasers in each bag. And his sister puts X stickers in each bag, so she adds some items. She adds an X number of stickers. So now we have a tape diagram like we saw in the previous problem, and we can solve them the same way. We have 1, 2, 3, 4 equal parts that total 44. So 44 divided by 4 equal parts is 11. So the total in each box is equal to 11. 3 plus X is equal to 11. So 3 plus what number is equal to 11? 3 plus 8. 3 plus 8 is 11, so X is equal to 8. And we know that X is the number of stickers in each bag, so his sister put 8 stickers in each bag. So we also see that this problem has an interactive digital version available. So I'm going to take you to the website and show you how to use that tool. Okay, so here we are on the Open Up Resources website. And here's our problem. Noah and his sister are making gift bags for the birthday party problem, number 1. So here's the little interactive tape diagram we can make. So the first thing I'm going to do is I'm going to click on the Show Controls. So this will allow me to put the different numbers and variables and make my tape diagram. So I know the total is 44, so I'm going to go down in here in the total and type in 44. Then how many equal parts? Well, he has 4 bags, so I'm going to change this part to 4 and hit enter. Now for each part, I'm going to label them. I had 3 pencil erasers in each bag, plus X stickers. And then I had a total of 44. So that's what my tape diagram would look like online. So let's go down to the second one. Problem number 2, because that's going to look a little bit different. So number 2 says Noah's family also wants to blow up a total of 60 balloons for the party. Yesterday they blew up 24 balloons. Today they want to split the remaining balloons equally between 4 family members. So again, I'm going to click on my Show Controls. How many equal parts? Well, I have 4 family members, so they want to split the balloons into 4 family members. 4 family members. And we don't know how many balloons they're each going to have. We're just going to label them X. But you notice, where is the 60 balloons? So we want some different kind of parts in here. And we just want one that's going to represent our 60 balloons. Oh, not 60 balloons. 24 balloons. The total number is going to be 60. So that now gives us our 24 balloons that they blew up yesterday. And then the remaining balloons, they split between the 4 family members. 1, 2, 3, 4. And X is the remaining balloons they gave to each family member. For a total, this number plus this number would be 60. So let's go ahead and solve this. Okay. So if we had to draw it out, this is what it would look like. We have our 24 balloons and the 4 family members with an X number of balloons with a total of 60. So if this right here is 24, then this amount is 24 from 60. So if we subtract 24 from 60, we get a total of 36. So this amount right here altogether is 36, because 36 plus 24 is 60. So if we take this 36 and divide it into 4 equal parts, 36 divided by 4 is equal to 9. So that means that each family member got 9 balloons. Okay, let's go to the last problem. Noah's family bought some fruit bars to put in the gift bags. They bought 1 box each of 4 flavors: apple, strawberry, blueberry, and peach. The boxes all had the same number of bars. Noah wanted to taste the flavors and ate 1 bar from each box. There were 28 bars left for the gift bags. So after Noah ate 1 from each box, there were 28 total. That was a bad line, but 28 total. So they had 4 flavors. So it had 4 boxes of fruit bars. So I'm going to split this into 4 equal parts. And there was some number of fruit bars in each box, right? We'll say there's X number of fruit bars in each box. But then Noah ate 1. So he took away 1 from each flavor, and then we're left with 28. So if we take this 28 and divide it into 4 equal parts, 28 divided by 4 is equal to 7. So that means now each box has 7 bars in it. But that was after he ate 1. So what number minus 1 is 7? That's pretty easy. That's 8, right? 8 minus 1 is equal to 7. So X, the number of fruit bars that were originally in each box, was 8. Let's take some notes and talk about some ideas on what parts of why or tape diagrams are useful and how we can use them to solve problems. So what are some ways that tape diagrams give information about a story? Well, they show a picture, right? They show a picture of the parts of the problem. They show us the known parts. They show us the known parts as numbers, and this is from the first problem we looked at today. And they also show us some unknown parts as variables. And then they also show us what the total amount is. So let's look at some strategies on how to create a tape diagram. First, create the rectangle. You could just leave it blank, just create a blank rectangle. And then find the total. What's the total amount we're talking about after maybe some things are added or subtracted or combined in here? What's the total amount after everything happens in the tape diagram? So we want to write the total. Then we want to split the tape diagram into parts that we know. We can make equal parts and put variables in there if we have something that's split up equally among some people or something like that. We can make parts for the known values, and we could put numbers in those. That's it.